What if I told you that Lewis Hamilton's worst qualifying result in more than 360 attempts was not just a disaster on the timesheet, but the beginning of an investigation that led Fred Vasseur to uncover something inside the Ferrari SF25 that changed the entire understanding of the session? You saw Hamilton finish 20th in the rain, but you did not see the detail that triggered Ferrari's alarm. In the middle of the spray, during his final preparation lap, Hamilton ran over a track cone, a moment that looked harmless but carried consequences no one realized in real time. And when Vasseur inspected the underside of the SF25 after qualifying, he found signs of contact beneath the floor, evidence that the cone strike may have disrupted the ground effect airflow and stripped the car of the downforce Hamilton desperately needed on a surface described by drivers as driving on ice. Stay right here, because once you hear what Vasseur concluded about the cone impact, the tire temperature collapse and the radio confusion that ruined Hamilton's final chance, you will understand why Las Vegas 2025 became the lowest point of his entire season. The Las Vegas qualifying session unfolded under a cold and relentless rain that transformed the circuit into one of the most unpredictable environments of the entire season. Water pooled around braking zones, the asphalt refused to generate heat, and the spray created a dense curtain that reduced visibility to a narrow tunnel ahead of the car. Lewis Hamilton entered the session determined to extract performance from the Ferrari SF25, but from the opening lap it became clear that the car was struggling to adapt. The tires lost energy almost as fast as they gained it, and Hamilton felt the balance shift beneath him in ways that offered no stability from corner to corner. As conditions worsened, the challenge escalated into something far more serious. Hamilton reported that the front end refused to respond on initial turn-in, while the rear stepped unpredictably the moment power was applied. Engineers watched live telemetry that revealed a pattern of collapsing tire temperature, confirming that the rubber was falling below its operating window even before he reached the final sectors of each lap. The cold airflow over the surface and the constant water film stripped away any confidence Hamilton attempted to build. Every adjustment he made to search for grip only highlighted how disconnected the SF25 felt from the circuit. Then came the moment that would change the entire narrative of the night. In the reduced visibility caused by spray, Hamilton ran over a track cone that had been dislodged earlier in the session. The contact seemed minor from the outside, almost invisible in real time, yet ground effect cars are uniquely sensitive to any disturbance beneath their floors. The incident happened during a preparation lap, not during a push lap, meaning Hamilton approached his next timed attempt without knowing the aerodynamic platform may have been compromised. His radio messages reflected rising confusion as the car reacted more aggressively to wet patches and lost stability mid-corner. Ferrari attempted to guide him through adjustments, but the behavior of the car deteriorated with each run. The SF25 bounced in places where it normally remained planted, slid across standing water, and offered no reassurance under heavy braking. Hamilton's final flying lap showed the full extent of the problem. The car washed wide at turn entry, refused to bite in the middle phase, and delivered almost no traction on exit. Each sector was slower than the previous one, and by the end of the lap, the deficit placed him in the 20th position, a result so far outside expectations that the garage fell silent the moment the timing screen updated. When Hamilton returned to the pits, the Ferrari crew immediately began questioning what had gone wrong. The rain alone could not explain the scale of the performance collapse, and the onboard comments Hamilton made during the lap suggested the car behaved inconsistently even when he followed the correct tire management procedures. Fred Vasseur ordered a detailed inspection of the SF25, focusing especially on the area most vulnerable in wet conditions, the underside of the floor. What they found next connected directly to the moment the cone was struck, and it became the center of Ferrari's internal investigation. That discovery changed the entire interpretation of Hamilton's qualifying. Evidence of contact beneath the floor suggested that airflow disruption may have robbed the car of downforce exactly when grip was already at its lowest. For a machine as sensitive as the SF25, this combination was devastating. Cold tires, unstable downforce, and a thin margin for error created the perfect storm that placed Hamilton in the last position on the grid. And now, the question that follows is simple. Was this a one-off incident caused by pure misfortune, or did Las Vegas expose a deeper vulnerability in Ferrari's design that could haunt them in the closing stages of the season? The central problem Hamilton faced in Las Vegas qualifying began the moment he tried to build tire temperature on a surface that refused to cooperate. The rain turned the circuit into a sheet of cold glass, and the SF25 struggled more than any other Ferrari model in recent years to generate the thermal energy needed to stabilize its balance. Hamilton felt the front tires fall beneath him in the opening sector, and as the rubber cooled further, the rear end lost the traction required for any meaningful rotation. From the first lap onward, the car behaved like it was sliding across standing water rather than interacting with the asphalt beneath it. As the session progressed, the SF25 exposed a deeper structural issue. Every car on the grid suffered from low grip, but Hamilton's machine showed a complete failure to hold tire temperature for even one full lap. Engineers monitoring telemetry saw numbers drop into ranges more typical of installation laps rather than qualifying attempts. Each time Hamilton attempted to push, the balance shifted drastically between turn entry and exit, leaving him no foundation to build momentum. This created a feedback loop where cold tires destabilized the aero platform, and the unstable platform accelerated tire cooling even further. The problem intensified when the spray thickened and visibility collapsed. In those conditions, drivers depend on the consistency of their cars more than the track surface, but Hamilton had no such reliability to lean on. The SF25 understeered into wet patches, snapped without warning on corner exit, and offered no sense of where the limit truly was. His radio messages reflected confusion rather than frustration, because even with his mastery in the rain, the car's behavior lacked any logical pattern. Ferrari needed at least one stable reference lap, yet every attempt dissolved as the tires dropped below their thermal threshold. Then came the moment that redefined the entire session. During one of Hamilton's final preparation laps, a cone displaced by another competitor remained in the racing line, partially hidden by the spray. Hamilton ran over it without having any chance to avoid it. The impact seemed insignificant, but the effect on a ground effect car can be immense. Even a small deviation in the geometry beneath the floor can disrupt airflow, decrease downforce, and destroy stability. Hamilton continued the lap unaware of what had happened, but the sudden deterioration in balance became the turning point Ferrari later identified as the catalyst for the qualifying collapse. From that point forward, the SF25 behaved like a completely different machine. The car no longer followed the expected aerodynamic patterns through the wet corners, and the fluctuations in downforce grew more severe. Engineers saw ride height numbers that made no sense for the conditions and lateral load values that indicated the car was no longer producing consistent suction beneath the floor. In wet weather, any disturbance in underbody airflow multiplies the instability caused by cold tires, and Hamilton found himself fighting a car that felt lighter, less predictable, and far more difficult to control than it had moments earlier. By the time Hamilton finished his last attempt and saw himself placed in the 20th position, the problem was bigger than a simple lack of pace. It was the convergence of rain, cold tires, and a hidden impact that destroyed the aerodynamic foundation of a car already struggling to adapt. This was not the type of session a driver can salvage with talent alone. It was a scenario where every variable worked against him simultaneously. And when the team brought the car back to the garage, they knew immediately that something beyond the weather had dictated the outcome, setting the stage for Vasseur's deeper investigation. The engineering analysis after Hamilton's 20th place in Las Vegas qualifying quickly grew into one of the most complex diagnostic efforts Ferrari had conducted all season. The SF25 depends heavily on ground effect stability, meaning the floor must channel airflow cleanly to generate downforce. Rain amplifies every weakness in the system, and the moment conditions deteriorated, the car struggled to maintain the suction effect needed to stay planted. Engineers tracking live data saw early signs that the aerodynamic platform was unstable, with oscillations in ride height and load values that suggested the car was fighting to maintain even a basic aerodynamic seal on the wet surface. This fragility became even more concerning when matched with the tire temperature data. The SF25 requires a specific temperature window to operate correctly, and Las Vegas offered none of it. The cold asphalt withdrew heat faster than the tires could accumulate it, and as the rubber cooled, the car lost the vertical load it needed to push air beneath the floor effectively. As a result, every time Hamilton tried to generate grip, the aerodynamic structure beneath him weakened further. Telemetry revealed that the tires were cooling throughout the lap, and the drop in core temperature was especially severe after the cone strike, pointing toward a compromised aerodynamic state. The cone impact itself became the focal point of Ferrari's internal investigation. Ground effect cars do not need large damage to lose performance. Even small abrasions, deformations, or surface disruptions beneath the floor can destroy the airflow profile. When Hamilton struck the cone in the spray, the team feared the worst even before bringing the car into the garage. Once the underside was inspected, they found traces of contact on areas of the lower structure that are critical for managing pressure. It was not a dramatic crack or break, but the mark suggested a distortion in airflow that could easily remove several tenths of performance per corner in wet conditions. Ferrari engineers cross-referenced the physical damage with telemetry captured after the cone strike, and the match was clear. Ride height became more erratic. Downforce values fluctuated unpredictably. Lateral stability dropped sharply in the middle phase of corners, especially where standing water increased load variation. This kind of instability creates a cascading effect in a ground effect car. Once airflow beneath the floor becomes turbulent, the aerodynamic platform generates inconsistent forces, which then destabilize the tires, which then further reduce the available grip. Hamilton felt this directly through delayed responses and sudden rear movement that did not align with his inputs.